Koji Sato, the CEO of Toyota, paused mid-sentence as the overhead lights dimmed. The sleek form of the Aqua engine was now illuminated like some mythic artifact. It hummed quietly in the contained silence of the demonstration hall, seemingly powered by nothing more than a simple bucket of ordinary tap water. He didn't need to elaborate. The implication was clear. In that charged moment, an unspoken declaration hung in the air. This innovation could very well upend everything the EV industry stood for across Japan and then around the world. The ripples were instantaneous. Observers struggled to reconcile the familiar image of Toyota. Quiet, methodical, almost conservative, with this electrifying revelation. An onboard electrolytic reactor that separated hydrogen from water in real time, feeding a compact fuel cell and delivering power with no fossil fuels, no grid, no lithium, just water. A closed-loop hydrogen system, clean and almost poetic in its simplicity. The engine consumed tap or rainwater, refilled in a couple of minutes, and promised over 900 kilometers of range. The future didn't come draped in wires and batteries. It came in the elemental purity of a water molecule. Immediately, questions swarmed. How could Toyota have achieved something so revolutionary, so quietly? Sagecraft was subtle, yet powerful. He didn't scream that this was the end of electric vehicles. He let his creation speak for itself. The audience already understood. Refueling in 2 minutes with water, that alone dismantled years of infrastructure investments in charging networks, battery supply chains, lithium mining, and grid expansion. It was too elegant, too radical to ignore. Journalists scrambled for clarity. Was this a fuel cell? No. There was no high-pressure hydrogen tank, no external hydrogen station. The hydrogen was born inside the engine, on demand. The only byproduct was water vapor. That meant zero emissions, zero reliance on battery materials, and no requirement for rare earth elements. It was molecular fuel, pure and simple. In the marquee corridors of the EV industry, the shock was seismic. Battery giants, once reigning in headlines about market dominance, now found themselves confronting a new paradigm. Lithium futures dipped, stock charts wavered. Tesla, BYD, and Ariane all tentatively retreated into boardrooms, reassessing strategies. Traders whispered about stranded assets. Planners looked at charging infrastructure with fresh trepidation. At the same time, environmental groups erupted in applause. Here was a technology that offered a credible path toward decarbonization without further exploiting fragile ecosystems or inciting geopolitical tension over mineral mining. The possibility of mobility powered by water, a form and function fused with environmental ethics, had an almost mythic allure. At first, governments were, pretty cautious, but now they had started to pivot. Regulators scrambled to define new safety frameworks. Folks wondered, was a sealed reactor that split water on board truly safe across all temperatures, altitudes, and traffic conditions? And, hey, what about using it in cold climates where water freezes? Toyota's certifications, including Japan's top environmental and road safety clearances, definitely eased a lot of fears, but not all of them. Lobbyists, well, they started raising alarms. If water-powered engines really took off, what would happen to entire economies built on lithium, oil, or even electricity grids? Would desalination plants get repurposed? Would rainwater harvesting become a new focus for everyone? And through all this noise, Toyota just kept moving forward with honestly exceptional stealth and confidence. The Aqua engines were already rolling off the production lines at the Higashi-Fuji plant. The plan was for the first vehicles, starting with the MY-AQ, to hit the roads as early as the first quarter of 2026, but the ambitions didn't stop there. Commercial trucks and Lexus models were next up in the pipeline, and with exclusive patents on the electrolytic reactor, competitors just couldn't easily replicate the technology. Perhaps most intriguing was the modularity that hinted at future scalability. Toyota's engineers had designed the Aqua to be adaptable, with core components that could be scaled up or down depending on the application. A city bus could house a larger electrolytic chamber for greater hydrogen throughput, while a compact urban commuter might operate with a smaller, lighter system. This flexibility meant the technology could saturate multiple transport segments simultaneously rather than waiting for a trickle-down effect from one class of vehicle to another. In research institutions, the unveiling triggered a renewed focus on complementary technologies. Advances in atmospheric water harvesting, for example, could pair seamlessly with the aqua, allowing vehicles to generate their own water supply in humid climates. New materials, for even more efficient electrolysis, could push the system's performance further, while AI-driven route optimization could reduce energy demands to the absolute minimum. The social implications were equally significant. In developing regions where access to fuel is often limited, or, just way too expensive, a vehicle that could run on collected rainwater or locally sourced non-potable supplies could really transform mobility. Farmers, traders, and rural healthcare providers could travel farther and more frequently, all without the economic strain of conventional fuel costs. Mobility itself could become more equitable, no longer restricted by the location of fuel supply chains. As engineers demonstrated the ease of operation to small groups in the hall, it became clear that user interaction had been a design priority. A single dashboard indicator displayed water levels, projected range, and hydrogen production rate in an intuitive format. There were no complex controls for the driver to manage. The system's AI handled everything from flow rates to temperature balancing. The driver's only task was to ensure the reservoir was topped up, a task so straightforward it required no special training. For Toyota, the unveiling was also a subtle statement of independence from dominant industry trends. While other automakers were betting heavily on solid-state batteries or extended-range EVs, Toyota had stepped sideways into a space with little direct competition. This move insulated the company from some of the fiercest battles over battery supply contracts and charging infrastructure partnerships. It also positioned them as a supplier of not just vehicles, but of an entirely new propulsion ecosystem that others might license in the future. The demonstration concluded not with a roaring finale, but with a quiet, sustained hum that seemed to echo the profound shift it had just initiated. As the lights in the hall returned to normal, the small, unassuming unit sat silent, its potential now fully unleashed into the world. The attendees, a mix of journalists, analysts, and industry insiders, filed out not with the usual chatter of a corporate event, but with a pensive, almost stunned silence. The questions that now occupied their minds were no longer about horsepower or torque, but about the very foundations of global energy and transportation. In the days that followed, the initial shockwave began to crystallize into tangible action. Toyota's stock, after a period of volatile trading, began a steady and unprecedented climb as investors recalibrated their understanding of the company's future value. It was no longer just an automaker. En Hussein Enderden, Omar Jussadab, in Saykir Dauderden. It was now the sole proprietor of a foundational technology, a position reminiscent of the early days of the microprocessor. Financial analysts struggled to find a historical precedent for such a sudden and complete disruption of an entire industrial sector. Competitive reactions evolved from dismissive skepticism to frantic behind-the-scenes mobilization. Engineering teams across the automotive and energy sectors were hastily reassembled and tasked with a single objective: to understand and, if possible, circumvent Toyota's patents. The geopolitical landscape also began to tremble. Nations rich in lithium, cobalt, and nickel watched their projected economic futures soften overnight. Conversely, countries with advanced manufacturing capabilities and existing water infrastructure networks saw a sudden strategic advantage. Diplomatic conversations subtly shifted. Trade delegations began including water resource managers and desalination experts alongside traditional energy officials. A new term, hydrodiplomacy, entered the lexicon.